And welcome back, and it is the 9th of May, higher plus 5 a day. And let's just go straight to the first one. Right, so we have a quadratic inequality, i.e. an inequality, we have a quadratic. So therefore, it's the method, hopefully you've seen before, it's a pretty standard method. So the first thing I need to do, well actually the first thing to do is recognize that this is an upward sloping quadratic, a happy quadratic. And I need to know where it crosses the axis, because I know it's going to be less than 0 between these points. And the way I'm going to do that is I'm going to factorize, which is going to give me x plus 5, x minus 3 is less than 0, which means this gives me a 3 and this gives me a minus 5. So minus 5 and 3, I want all values between, so therefore it's going to be minus 5 x 3. Now because that doesn't have an equal sign, it's what's called a strict inequality, my answer also is a strict inequality. Not too bad that first one, is it? Next one. Okay, so we've got a function. Now actually I was going to say this doesn't look too bad, then I can see we've got one over to the right. So let's do this one first. So find the inverse function of f of x. What does f of x do? Well, f of x times this by 7 and then takes away 2. So the opposite of that is to add back 2 and then divide by 7. So that is my inverse function. You don't need the brackets, but I'll put them there anyway. Then I need to find f of 2. So the way I'm going to do that is I'm going to find f of 2, which is to put 2 into the f equation. And so that's going to be f of 14 minus 2, which is 12. And then I'm going to do f to that again. So that's going to be 7 times 12 minus 2, or 7 times 12 is going to give me 84, minus 2 is going to give me 82. Good question. Composite functions question. Next question. The histogram shows information about the ages of rugby league players registered for competition, 240 players between 36 and 40. Okay, 48. Sorry, that's me not reading the question correctly. So therefore, this is going to be 240, which means I can use that to work out my scale. A player is chosen at random. Estimate the probability that the rugby player is under 33. So 33 is going to be here or below. Okay, so the first thing I need to do is I need to fill in my boxes, don't I? Now, so I can help you see what I'm doing. I'm going to call this A, B, C, D, and E. Just means it's a bit clearer. I'm going to do all my working here. So here's A, B, C, D, and E. Now, think about the class widths. So be careful because each square is 3, which means that's 21. It means that is 27. This is 33. And I don't need those, so that's okay. Okay, so let's do class widths first. In other words, widths of the rectangle. So that's going to be 3, 3, 6, 6, and 3, 6, 9, 12. And then I need the frequency density. Well, and then I need the frequency. Now I know, because it tells me in the question this is 240, which means this must have a frequency density of 20, which means I know this is 20, which means I know each of these little squares is going to be 10. So now I can write my frequency density on there. There we go. Which means now I can work out my frequency. So let's again do it in order. So A has a height of 70. 70. Okay, you join me back where I'm just adding all these up. So just to be clear what I've done, there's a cut in the video there. So I have worked out by looking at, let's look at D here. So I've used the scale very carefully because these are not exact numbers. I've used the scale to work out the frequency density, which here is 58. I've multiplied that by the class width, and that has given me the frequency, in other words, the area of each of these boxes. Then I've added all these areas up to give me the total amount of what am I doing? About the ages, to give the total ages of all the rugby players. Then what the question wants me to do, so it's a probability question. So it says, estimate the probability that choosing a person at random is under 33. So these people here are all under 33 because they're between 0 and 21, as are these people here, as are these people here, and as are half of these people here. So in other words, I want to add up all of this, all of this, all of this, and half of this. So let's do that. So 210 plus 270 plus 492 plus half of 348. So 348 over 2 in my calculator. And that gives me 11146. These are not great numbers, are they? Therefore, the probability of being under 33, so that's just terminology for probability under 33, is equal to 1146 over 1560. Now, well, let's simplify. So in my calculator, divide by 1560. It does a little bit. So that simplifies down to 191 over 260. That's a good question. And I have to say that these sorts of questions have been coming up a bit more recently. So do make sure you're okay with that. I've used the data I'm given to work out the frequency density. Then I work out all the values, add them all up, allows me to do a probability question. Good question. Next question, in fact, final question today. Find the shortest possible distance between the line and the origin. Now, each time I do this, I get people asking me how to do it. So hopefully if you're watching along and keep watching these videos, you should know what I'm going to do now. So I have a line that is something like this. Doesn't matter if that's precise, but it looks something like this. And the shortest distance is going to be a line that is perpendicular to it that goes through the origin. In other words, goes through the point that I care about. So the question is really twofold. What is the equation of the line that is perpendicular through the origin? What is the point A where the two lines meet? And therefore, what is the distance from O to A? That's going to be my process. So let's do that. So let's start by working out, well, I know the gradient of the line I'm given is 4, which means the gradient of the perpendicular line is negative reciprocal minus 1 over 4, which means the equation, I'm going to do it in red. So the equation of the red line is minus a quarter x. There's no c term because it goes through 0. Then I want to find out where minus a quarter x is equal to 4x plus 5. Okay, if you've seen my videos before, you'll know my next step now is to multiply everything by 4. So that gives me minus x equals 16x plus 20. It just gets rid of that slightly horrible fraction, makes it a bit easier. Then I'm going to add, which way around should we do it? Yeah, so let's add x to both sides and take away 20. So that means that 17x is equal to minus 20, which means that x is equal to, well, it's not a nice number, but it's minus 20 over 17. Not a nice number at all. I also know from this equation here that the y value is going to be minus a quarter of that. So the y value is going to be, well, minus 20 divided by minus 4 is 5. So the y value is going to be 5 over 17. Crucially, let's be clear, I know therefore my a coordinate is going to be minus 20 over 17 and 5 over 17. And all I need to do then, just basic Pythagoras, is I need to work out the distance from O to A. And that's, as I say, just Pythagoras. So it's going to be 20 over 17 squared plus 5 over 17 squared, which is, well, I can't do that in my head, so calculator out. And the calculator actually tells me 5 root 17 over 17. But I'm going to give a number anyway. So press the SD button. That gives me 1.212678125. Which I'm just going to call 1.2122 decimal places. And that's it, question done. It got a bit harder today. I thought those questions, obviously the first one was okay. Second one, not too bad. Those last two questions, definitely a bit more tricky. As I say so often, important thing is though, not too tricky. Definitely something you should be okay with. As ever, leave a comment below. Let me know how it went for you. Do like and subscribe, and I'll see you tomorrow. Thanks all.